Hello. Yes, we welcome you back to PSSB with me, Richard here. Tonight we are looking at this question. It says that sulfuric acid has a pH of 2.5. Calculate its concentration. Okay. And how do you go about that? Okay, this is what you have to know. That, okay, we know the pH and the sulfuric acid. So, and we know the expression for pH. What is it? pH is equal to negative log hydronium ion concentration. Okay. Next is to substitute. So our pH is known, is 2.5. And this one is equal to negative log hydronium ion concentration. How do you go about this? You have to know that our concentration of hydronium ion concentration will be equal to 10 exponent 2.5, actually negative 2.5. So what you get out of that will be the concentration of hydronium ions. And it's going to be, that is it. So what we have there is the concentration of hydronium ions. Okay. So what is the next step? Next step is to have our equilibrium for ionization of sulfuric acid. So what is it? We know that sulfuric acid is H2SO4. It is a strong acid, so it completely ionizes to give you hydronium ions or hydrogen ion plus sulfate. Okay. That is it. So what do we get from this expression? You get the mole ratio. This one shows that 1 mole of sulfuric acid ionizes to give you 2 moles of hydrogen ions or hydronium ions. Okay? But we know the concentration of hydronium ions. So we put it here. It is a 0.0031. And here, we don't know it, but it's calculatable. From here, you have to remember something, that these are directly proportional ratios, which are solved by cross multiplication. So from here, what are we going to say? We're going to say 2x is equal to 0.0031. So giving us x, which is equal to 0.0031 over 2. So there we are. So this is the concentration of sulfuric acid in moles per cubic decimeter. Then comes this question. It says that potassium hydroxide has a pH of 13.2. Calculate its concentration. Okay, how do you go about this? Okay, you have to remember that the pH expression is pH is equal to negative log hydronium ion concentration. Okay. And pH is known. It is 13.2. So which means that 13.2 is equal to negative log hydronium ion concentration. Okay. So the question is, what is the concentration of hydronium ion? Okay, it is going to be equal to the antilog of that one, which is going to be 10 power or exponent 13.2. Okay, this one gives you the concentration of hydronium ions. Yeah, so this is it. We have the concentration of hydronium ions. But the question, what's concentration of potassium hydroxide? So what do we do? Okay, we can say calculating what? Concentration of potassium hydroxide. Okay, the link between hydronium ion and potassium hydroxide is through water dissociation constant. So what do we know? We know that Kw is equal to hydronium ion concentration into hydroxide ion concentration, which is equal to 1 times 10 power minus 14. But so from here, what do we do? We substitute for hydronium ion concentration. We have them. So you say, okay, 6.3095 times 10 power minus 14 for hydronium ion concentration into this, which is equal to 1 times 10 power minus 14. So which means that now we can calculate the hydroxide ion concentration, which is going to be 1 times 10 power minus 14 over 6.3095 times 10 power minus 14, giving us, this as the concentration of hydroxide ions in moles per cubic decimeter. So what do we do? Now we know, what do we know? We know that our potassium hydroxide dissociates to give you potassium ions plus hydroxide ions. And we must know that potassium hydroxide is a strong base. So what does that mean? That all potassium hydroxide completely dissociates to give you this. The implication there is simple. What does it mean? That every 1 mole of potassium hydroxide generate 1 mole of hydroxide. So this gives you this. What does it? It means that the concentration of hydroxide ion is equal to the concentration of potassium hydroxide, which is equal to 0.158 moles per cubic decimeter. So that is that. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. We thank you for your time. We urge you to subscribe, to comment, to like, to share. We remind you that this channel specializes in physical sciences grade 12, 11, and 10, and natural sciences grade 8 and 9. We recommend that when you're using the channel, please use the playlist. Just go to the playlist and select the material which belongs to your level. For grade 8 and 9, look for natural sciences grade 8 or natural sciences grade 9. For grade 11 and 10, look for physical sciences grade 11 or physical sciences grade 10. As for grade 12, each chapter is presented independently. So just look for the chapter of your choice, and then you'll have all the material which belongs to that chapter. We thank you. We cherish you. Yeah, see you next time. Bye-bye.